Hey everyone, and welcome to another deep dive. Today we're taking on something truly mind-bending. Time travel.
Ooh, time travel.
Yeah, but not the kind with like spaceships or, wormholes.
Right, right.
This is about time dilation,
Okay.
which is a real phenomenon. It really messes with how we normally think about time, like in our everyday lives.
Uh,
Our source material for this one is an audio file called howtotimetravel.mp3. And let me tell you, it's packed with some crazy ideas.
oh, wow.
We're talking about how time might pass differently on a massive planet like Jupiter.
Okay.
And get this, even how your own ankle
Hmm.
experiences time differently than your wrist.
Really?
Yeah.
That's wild. What's so fascinating to me about time dilation is that it's happening constantly,
Right.
everywhere. It's not just some theoretical physics concept,
Yeah.
It's built into the fabric of reality.
Okay. So before we get too far down the rabbit hole of, my ankle experiencing time differently,
Yeah.
can we just back up for a second? What exactly is time dilation?
Okay.
And how does it work?
So imagine space-time as this, like a giant flexible sheet, right?
Okay.
And heavy objects,
Mm-hmm.
like planets and stars, they create these dips in this sheet.
Okay.
Sort of like if you put a bowling ball on a trampoline.
Gotcha.
So these dips represent the warping of space-time
Okay.
caused by gravity. Now think about rolling a marble across that trampoline.
Yeah.
The marble's path is going to curve because of that dip.
It is, yeah.
That's kind of similar to how gravity affects objects, including light.
Right, so planets and stars make these dips in space-time.
Yeah.
But how does that actually affect time itself?
Well, the deeper the dip,
Uh-huh.
the slower time runs in that region. It's like time itself gets stretched out.
Okay.
The closer you get to a massive object.
Interesting.
And that is what we call gravitational time dilation.
So if Earth is making a dip, Jupiter, which is way bigger, must be making a massive dip in space-time.
Exactly. Much bigger dip.
So does that mean time really does run slower on Jupiter, like the source said?
Yes, precisely.
Wow.
The source material, it notes a difference of about 20 nanoseconds.
Okay.
So for every second on Jupiter,
Mm-hmm.
a tiny bit more time passes here on Earth.
Okay.
It's a measurable difference, which is crazy when you think about it. It's just from Jupiter's huge gravity.
That's pretty amazing, yeah.
Yeah.
Okay, that's starting to make sense to me.
Yeah.
But the source also said that the Earth's core
Yes.
is actually younger than its surface.
Right.
How is that even possible?
That's where it gets really interesting.
Yeah. It seems like it should be the opposite since the core formed first.
You would think, right. But
Yeah.
the core is under so much pressure,
Uh-huh.
it's way denser than the surface.
Yeah.
So that dip in space-time,
Right.
it's more pronounced there.
Okay.
Because of this intense gravity, time at the Earth's core actually runs a bit slower
Oh, yeah.
than at the surface. And over billions of years, this tiny difference has really added up.
So how much younger is the Earth's core because of this time warp?
Scientists estimate about 2.5 years younger
Really?
than its surface.
Wow.
It's a really great example of how time dilation isn't just this far-off thing,
Yeah.
It's happening right here.
Under our feet.
Exactly.
Wow, this is making me rethink my whole concept of time. The source also mentioned something about a watch on your ankle running slower than one on your wrist. Is that really true?
It sounds crazy, but it is, at least theoretically.
Okay.
It's all because of gravity. So your ankle,
Uh-huh.
it's a little bit closer to Earth's center of gravity
Okay.
than your wrist is, meaning it's deeper in that, gravitational dip.
Right.
And this tiny difference in gravity means a tiny difference in the flow of time.
So even though it's like a super small difference
Yeah.
that we wouldn't even notice in our regular lives,
Right.
the watch on my ankle, technically experiencing time slower.
Exactly. Over thousands or even millions of years,
Right.
that tiny difference could become measurable.
Okay.
It shows that time dilation isn't just this far-out cosmic phenomenon.
Yeah. Yeah.
It's influencing everything,
Yeah.
even at the smallest level.
This is where things start to get really wild.
Okay.
What about black holes?
Yeah.
I mean, those things warp space-time to, the extreme, right?
They do. Black holes are like the ultimate time dilation example.
Okay.
So imagine approaching the event horizon,
Uh-huh.
the point of no return around a black hole.
Right.
As you get closer, the gravity gets so intense
Yeah.
that time basically slows down to a crawl
Wow.
compared to someone watching from a safe distance.
So, like, theoretically, if I could hang out near a black hole's event horizon for a bit
Yeah.
and then come back to Earth,
Uh-huh.
everyone I know would be long gone.
Yeah.
Like, I'd be in the future.
That's the idea.
Oh.
Not that it's possible with our technology now, but it really shows you the potential of time dilation.
Yeah.
You might age a tiny bit. Well, decades, centuries, even millennia pass on Earth.
Okay, so this whole concept of time slowing down the closer you are to a black hole,
Yeah.
what's the science behind that?
It goes back to Einstein's theory of general relativity,
Okay.
which totally changed how we understand gravity. The theory says that gravity isn't a force like the classic way we think of it,
Right.
but it's actually a curvature of space-time.
Okay.
So these massive objects, they create these dips in space-time.
Yeah.
Anything passing through them, even light, experiences a slowing down of time.
So it's not that clocks run slower near a black hole, it's that time itself
Like,
is
right.
actually flowing differently.
Yeah, time isn't this absolute universal constant
Yeah.
like we tend to think it is.
Right.
It's connected to gravity and motion,
Uh-huh.
and it can be warped and stretched in ways that are hard to wrap our heads around.
This is mind-blowing. All right, so we've talked planets, black holes, but the source also mentioned this thought experiment
Right?
about constant 1G acceleration
Uh-huh.
and how it could, like, make space travel possible across huge distances.
It's a cool thought experiment. It says that if you could keep a constant acceleration of 1G, the gravity we feel here,
Right.
you could kind of use time dilation to travel between stars. It mixes real science with a bit of sci-fi.
I'm intrigued, but I'm also a little skeptical. How does accelerating at 1G let you travel across such huge distances?
Well, it's all about velocity-induced time dilation.
Okay.
The faster something goes,
Uh-huh.
the slower time passes for it relative to a stationary observer.
Right.
As you get close to the speed of light, this effect gets really strong.
Okay.
So with constant 1G acceleration,
Yeah.
you'd be constantly speeding up,
Right.
which would lead to noticeable time dilation.
So you're saying if we could build a ship that could accelerate at 1G constantly, we could
Yeah.
reach distant stars within a human lifetime, even though they're light years away?
It's theoretically possible. It's like taking a shortcut through time
Wow.
because of time dilation. But this is all super theoretical, of course.
Right.
The technology to do that, to maintain that acceleration, is a long way off. We'd need unimaginable amounts of energy and a ship that could handle it.
Okay, so while a 1G acceleration spaceship is just a dream for now,
Yeah,
the idea is still fascinating. It makes you wonder about what's possible
for sure.
when we start to really understand physics
Uh-huh.
and how to manipulate it.
Absolutely. And that brings us to another mind-blowing idea from the source.
Okay.
The idea that our view of time as this flowing river might be an illusion.
Whoa.
What do you think about that?
Honestly, that's a tough one to wrap my head around. I mean, I can feel time passing right now.
Right.
It feels real to me. But I'm open to having my mind blown.
Okay, good.
How can time be an illusion when we experience it so clearly?
Well, think about this. What if all of time, past, present, future, all exists already? Not like a river, but like a vast, unchanging landscape.
So you're saying time is like a frozen lake.
Okay.
And our experience of it is like skating across the surface.
Yeah.
We only see one point at a time.
That's a great analogy.
Wow.
It's like saying the whole story of the universe is already written
Okay.
from beginning to end. But we can only experience it, one chapter at a time.
Okay. That's a heavy concept. But if all of time already exists, does that mean we don't have free will? Are our choices meaningless if the future is already set?
That's a big question.
Yeah.
And it takes us into philosophy and the whole debate about determinism versus free will.
Right.
It challenges what we think we know about choice and the nature of reality.
This deep dive is really pushing my understanding of time. But before we get too deep into philosophy, can we explore a little more about how the static view of time actually works? Like, if the future is already out there, how do we explain things changing?
Right.
Like people aging or the seasons changing.
Yeah.
It still feels like time is moving forward.
That's where entropy comes in. Entropy is a measure of disorder in a system. The second law of thermodynamics says that entropy always increases over time.
Okay.
Think of it like a messy room. It just gets more disordered
Yeah.
unless you actually tidy it up.
Right.
So what we experience as time passing
Uh-huh.
might just be us observing things becoming more disordered.
Okay.
It's like watching a series of snapshots,
Yeah.
each one with slightly more entropy.
Uh-huh.
And our brains interpret that as time moving forward.
So each moment in time has like a specific level of entropy.
Yeah,
And we're basically moving from lower entropy to higher entropy.
exactly.
And that's what we're perceiving as time.
It could be.
This is really stretching my brain.
Yes.
So if time isn't this flowing river and the future's already out there, what does that mean for our choices? Do they even matter in this static view of time?
That's the big question, right?
Yeah.
If the future's fixed,
Right.
it seems like our choices wouldn't matter.
Yeah.
But what if our choices are part of that fixed future?
Okay.
Like they're built into it.
So our choices are predetermined,
Yeah.
but they're still important for how the story unfolds.
Yeah.
It's like the script of a movie is already written,
Right.
but the actors still have to play their parts
They do, yeah.
to bring the story to life.
It's a deep philosophical concept
Yeah,
that challenges what we think about free will and destiny.
right.
But we have to remember,
Yeah,
these are all just theoretical ways to look at some very complex physics.
right.
We're still figuring out how time works.
Yeah.
There's a lot more to learn.
Well, this deep dive has definitely given me a lot to think about.
It's pretty amazing to think that something as seemingly simple as time
Right.
can be so complex
Mm-hmm.
and mind-boggling.
It really is. Time is, this fundamental part of the universe.
It is.
And the more we learn about it, the more we realize how much we don't know.
Exactly.
It's a constant reminder to stay curious.
Yeah,
Keep exploring the mysteries around us.
absolutely.
Yeah,
It really makes you think about how much control we actually have.
it does. But shifting gears a little bit, the source also pointed out that time dilation, it's not just happening out in space with black holes and starships and all that.
Right.
It's affecting us right here
Yeah.
on Earth, even in our daily lives.
All the time. Absolutely. We talked about how the Earth's core is younger than its surface because of the strong gravity there.
Right.
But that same idea, it applies everywhere on Earth, just
Yeah.
on a smaller scale.
So even those tiny differences in gravity, they create tiny differences in how time flows.
Exactly.
I'm thinking back to that ankle watch example. Is that why the source brought that up?
Yeah.
To show just how widespread time dilation is.
Precisely. It's a great example, even though it seems small. It shows how pervasive time dilation really is. It affects everything, even if we don't notice the effects in our daily lives.
It's like time dilation is this hidden force shaping the universe, from giant galaxies all the way down to us.
That's a great way to put it. It's woven into reality, affecting everything from how planets orbit to how clocks tick.
It makes me wonder, if time dilation is happening all around us, even if we don't see it, what are some ways it affects technology? Like, are there practical uses for this seemingly abstract concept?
There are, and they're more common than you'd think. One of the best-known examples is GPS. GPS satellites rely on these super precise atomic clocks,
Right.
but those clocks are affected by time dilation, both gravitational and velocity-induced.
Wait, how are GPS satellites and time dilation connected? I'm not picturing it.
Well, because the satellites are orbiting Earth really fast and they're high up,
Uh-huh.
they experience time differently than us down here on the surface.
Uh.
Their clocks actually run a tiny bit faster because of their speed and a tiny bit slower because they're farther from Earth's gravity.
So those tiny differences in time, because of the satellite's speed and altitude,
Yeah.
they actually matter for GPS.
They matter a lot. If we didn't account for those differences, GPS would be way off, the errors would build up, and you'd get wrong locations and directions.
That's incredible. So engineers have to factor in time dilation just to make our GPS work.
Exactly. They make tiny adjustments to the satellite clocks to compensate for these relativistic effects. It's pretty cool that understanding a concept like time dilation, which seems so abstract, can have such a real-world impact.
It really is. Are there other technologies where time dilation is important?
Definitely. Particle accelerators like the Large Hadron Collider are another example.
Okay.
These huge machines, they accelerate particles to almost the speed of light,
Uh-huh.
causing some serious time dilation.
So those tiny particles, they're basically time traveling as they zip around the accelerator.
Kind of, yeah. From our view, their clocks slow way down,
Wow.
so they live longer than they would if they weren't going so fast.
Okay.
This lets scientists study them in more detail and try to understand the building blocks of the universe.
That's amazing. It's incredible to think that something like time dilation is at work in our most advanced technology.
It really shows how connected science is. Breakthroughs in theoretical physics can lead to these practical applications that affect our lives, and time dilation is a perfect example.
This is making me appreciate how complex time really is. It's not just this simple line moving forward. It's dynamic, flexible, can be warped, stretched, even controlled.
Exactly. And while we've learned a lot about time dilation, there's still so much we don't know.
Yeah.
It's a frontier of science that's still challenging our ideas and leading to new discoveries.
As we wrap up this section, I'm curious, what are some of the big unanswered questions about time dilation? Like, where is our understanding still limited?
One of the most interesting areas of research is how time dilation connects to quantum mechanics. Quantum mechanics describes the world of subatomic particles, which is really bizarre.
Right.
And it's not clear how time dilation fits in with that.
So we're still figuring out how time dilation works at the quantum level, where things get even weirder.
Exactly.
Yeah.
Scientists are looking into whether time dilation might be part of some of those strange things they see in quantum mechanics, like entanglement and superposition.
Wow.
It's really exciting research that could change how we understand time A&D quantum mechanics.
This makes me think, if we could fully understand and control time dilation, what would be possible?
The possibilities are incredible. Imagine building spacecraft that use time dilation for interstellar travel.
Right.
We could explore distant stars within a human lifetime, or maybe even find ways to manipulate time dilation locally, creating devices that could warp time, revolutionizing things like medicine, computing, communication.
Sounds like science fiction.
It does, but who knows what the future holds? Maybe one day we'll unlock the secrets of time dilation and create technologies we can barely imagine today.
Before we move on to our final thoughts, I want to touch on something we talked about earlier. This idea of time as a static thing, where past, present, and future all exist at the same time. If that's true, does it mean the future is already decided? Is there a set path we're all following?
That's the core of the whole determinism versus free will debate. If the future already exists, do our choices even matter? Or can we have free will even with a static view of time?
It's a big philosophical question. I'm not sure there's an easy answer. But I think even if the future is fixed somehow, it doesn't mean our choices are unimportant or that our efforts to make a difference don't matter.
I agree. Maybe our choices, even if they're part of some grand plan, are what give meaning to our lives. It's like saying the story of the universe might be written, but we still get to choose how we play our part in it.
I like that. It reminds us that even if we're on a set path, we still have the power to choose how we walk it and what kind of impact we make.
Exactly. It gives us hope and a sense of agency. Even when we're talking about these mind-blowing ideas about time and fate, it suggests that even if the future is fixed, our choices still matter because they're part of what makes that future what it is.
I think we've covered a lot in this deep dive, from the basics of time dilation to some pretty wild philosophical ideas.
We have.
But I'm excited to hear your final thoughts on this topic. What's the one thing you'd like our listeners to think about as we finish up this exploration of time dilation?
Yeah, it's a nice way to think about it, for sure. It gives a little comfort, after all this talk about time being all warped and weird.
Yeah, it shows that while physics can explain a lot about the universe, some questions might always be more about philosophy, how we interpret things.
Right, right. As we've been talking about time dilation, it's become clear it's not just this scientific thing. It has these big implications for how we understand the universe, our place in it even.
Definitely. Time dilation challenges how we normally think of time, this absolute unchanging thing in the background of our lives.
It shows that time is linked to space, gravity, motion, all part of this fabric we call space-time.
Yeah, it's making me realize time is way more complex than we think it is.
Right.
And like we've seen, it's important for some of our most advanced technologies like GPS and those particle accelerators.
Yeah, it shows that understanding the universe better can lead to real improvements in our lives. Who knows what we could do if we understood time dilation even better?
That's what's so cool about this. It opens up so many possibilities. What are some of the most exciting areas of research that could unlock more of that potential?
One that's really interesting is looking for new particles or forces that interact with space-time in ways we haven't seen yet.
Okay.
Imagine finding a particle that could change gravity or warp time in a specific spot.
Wow.
The possibilities are pretty mind-blowing.
It sounds like science fiction.
It does, but as we've talked about, today's science fiction could be tomorrow's reality. What other breakthroughs could change how we understand time dilation in the future?
I don't know. It's hard to imagine.
Another fascinating area is studying extreme environments, like near black holes
Yeah.
or the very early universe.
Okay.
Those places push the limits of what we know about physics.
Right.
Studying them could teach us new things about time and gravity.
It seems like the more we learn about time dilation, the more questions we have. It's
Exactly.
like every discovery just leads to more mysteries.
It's what's so great about science. It's a constant journey of discovery.
Yeah.
You know, always learning, always challenging our ideas about the universe.
Well, as we wrap up this deep dive into time dilation, I'm feeling a sense of awe and wonder. It's amazing how much we still don't know about something as basic as time.
It really is. Time dilation shows us that the universe is full of mysteries. It should make us want to keep asking questions, keep exploring, and never stop being amazed by what's out there.
To everyone listening, thanks for joining us on this journey. We explored time dilation from the science to the philosophy.
Yeah.
I hope it made you curious and maybe changed how you think about time.
Keep asking questions, keep exploring, and never start being amazed by the universe.